Hi, my name is David VR, and I'm one of the armed statisticians in the Northern Plains Regional Field Office of NASS in Lincoln, Nebraska. Today, I would like to talk about nutrient or fertilizer applications in the ARMS Phase 2 questionnaire. The purpose of this section is to identify a nutrients or fertilizer used to produce a commodity of interest on the selected field. Fertilizer application data is used to analyze water quality and agricultural productivity issues and policies. Nutrient management practices help farmers adjust fertilizer applications to crop needs and reduce costs and losses to the environment. If a commercial fertilizer or nutrients were applied to the field, then code a yes equals 1 or a no equals 3. If they applied fertilizer, then how many applications were made to the field? Now, the number of applications of commercial fertilizer may not necessarily equal the number of fertilizers listed in the Section C table, meaning there was only one application, but there were two different fertilizers applied. For this table, you want to include all chemical nutrient or fertilizer materials applied specifically for the current year crop. You want to include nutrient or fertilizer applied in the previous fall for the current crop. And you need to include nitrogen products applied with herbicides to make the herbicide more effective. Items that should be excluded from the table: you're going to want to exclude micronutrients such as iron, zinc, and boron. You want to exclude lime and gypsum. Also exclude non-purchased manure and unprocessed manure produced and used on the operation. Exclude nutrients or fertilizers applied to previous crops planted in this field, even if the carryover was beneficial to the crop currently in the field. The table in this section is a critical part of the questionnaire. To better understand how to fill it out, let's talk about percent analysis versus pounds of actual nutrients. Fertilizer is made up of two things: actual nutrients, and for the ARMS Phase 2, we are only interested in 4 nutrients: nitrogen, phosphorus, potassium, and sulfur. N, P, K, and S. But there are many others as well. And the other part is carrier material, this filler or this other stuff. It takes a certain amount of nutrients to grow a crop. Let's say, for example, to grow a certain crop, it takes 105 pounds of nitrogen per acre, 35 pounds of phosphorus per acre, and 55 pounds of potassium per acre. We need to get this information recorded in the questionnaire. Now, there are 2 ways to record fertilizer applications in the questionnaire: the percent analysis, which is the most common and preferred method to record data, and by pounds of actual nutrients. You can look at these 2 methods like this. The percent analysis method is like recording a complete product, and the pounds of actual nutrients method is like recording the individual ingredients of a complete product. Percent analysis method is the complete product, the whole product of that fertilizer formulation. Some common fertilizers are urea, and this analysis is 4600. It's a dry product. 1034-0 is a liquid starter fertilizer. Monoammonium phosphate, or known as MAP, is 1152-0. It's a dry product. Diammonium phosphate, DAP, is 1846-0. And it's a dry product. The respondent booklet has a page of common fertilizers and their percent analysis. Pounds of actual nutrients is like the individual ingredients to a whole product, in this case, the nutrients. A fertilizer is written out by its percent analysis, has numbers and dashes in between. Take, for example, 26,510. The first number listed is always nitrogen. The second number listed is always phosphorus. The third number listed is always potassium or potash. And if a fourth number is present, say 26, 5, 10, 7, then the 7 is sulfur. The numbers represent the percentage of that nutrient in a fertilizer. What this means is that for any given quantity of this fertilizer, 26% of it will be nitrogen, 5% of it will be phosphorus, 10% of it will be potassium, and the remaining 59% will be the carrier material. So doing the math for a given quantity of fertilizer, say 150 pounds of 26,510, what this means is that 26% of 150 pounds equals 39 pounds of nitrogen, 5% of 150 pounds equals 8 pounds of phosphorus, 10% of 150 pounds equals 15 pounds of potassium. The rest will be carrier material, so the remaining 59% of 150 pounds is 88 pounds of the carrier material. As we just demonstrated with 26,510, each of those numbers represent the percentage of that nutrient in that fertilizer. This is essentially the percent analysis method. Now let's compare some consumer products to fertilizers. We'll start with a bag of peanut M&Ms. To keep this example simple, we're going to say that this bag of M&Ms is made up of two things, peanuts and the candy shell. Now, after much painstaking research and a trip to the dentist's office to get her crown, we'll say a bag is made up of 46% peanuts and 54% of the candy shell. Now let's compare the bag of peanut M&Ms to urea fertilizer. The peanuts compared to the nitrogen in urea, and the candy shell compares to the carrier material of the urea. So 46% is peanuts, 46 is nitrogen, 54% is the candy shell, 54% is the carrier material. The ratio of nitrogen to carrier works the same if I have a 100-pound bag of urea or a 500-pound bag of urea. 100-pound bag of urea is 46% is nitrogen, 54% is carrier. So 46% times 100 equals 46 pounds of actual nitrogen, and 54% of 100 pounds is 54 pounds of carrier. So if I have a 500-pound bag of urea, 46% is nitrogen, 54% is carrier. So 46% of 500 equals 230 pounds of actual nitrogen, and 54% of 500 is 270 pounds of carrier. Another dry product example is a Snickers bar. To keep this simple, we're going to say that this Snickers bar is made up of three things, peanuts, nougat, and chocolate. We'll say a bar is made up of 18% peanuts, 46% nougat, and 30% chocolate. Let's compare DAP 18460 fertilizer to the Snickers bar. The peanuts compare to the nitrogen in DAP, the nougat compares to the phosphorus, and the chocolate compares to the carrier material of the DAP. 18% is peanuts, 18% is nitrogen, 46% is nougat, 46% is phosphate, 36% is chocolate, 36% is the carrier material. The ratio of nutrients to carrier works the same regardless of the amount of fertilizer applied. Now let's compare a liquid product. To keep this comparison simple, we're going to say that this can of Sprite is made up of three things, lemon juice, lime juice, and water. We'll say the can of Sprite is made up of 10% lemon juice, 34% lime juice, and the rest, the 56%, is water. Now let's compare 10340 fertilizer to the Sprite. The lemon juice compares to the nitrogen in the fertilizer, the lime juice compares to the phosphorus in the fertilizer, and the water compares to the carrier material of the fertilizer. So 10% is lemon juice, 10% is nitrogen, 34% is lime juice, 34% is phosphorus, 56% is water, 56% is carrier material. The ratio of nutrients to carrier works the same regardless of the amount of fertilizer applied. Now let's compare another liquid product. For a simple product comparison, we're going to say that a lemonade is made up of two things, lemon juice and water. We'll say that the bottle of lemonade is made up of 32% lemon juice and the remaining 68% is water. So let's compare urea ammonium nitrate 3200 to a bottle of lemonade. The lemon juice compares to the nitrogen in the fertilizer, and the water compares to the carrier material of the fertilizer. So 32% is lemon juice, 32% is nitrogen, 68% is water, 68% is carrier material. The ratio of nutrients to carrier works the same regardless of the amount of fertilizer applied. So to record fertilizer by percent analysis in the table, there's a column for nitrogen, a column for phosphorus, a column for potassium or potash, and a column for sulfur. There's a column for the quantity applied and a column for the unit code of the quantity applied. So a dry product is code 1 for pounds, and a liquid product is code 12 for gallons. As you can see here in the table, we have 1152.0 and 85 pounds of product was applied. We have 1034.0, 5 gallons of this product was applied, and 0060, 120 pounds of this product was applied. So no fertilizer reported by the percent analysis will have a total NP and K greater than 85%. If you add the three numbers together, it will not be greater than 85. If sulfur is included in the mix, then this does not hold true. When you record by pounds of actual nutrients, you have 10 in the nitrogen column, 44 in the phosphorus column, 72 in the potassium column. The column for quantity applied is left blank when using pounds of actual nutrients. And column 4, the unit code is code 19, indicating that pounds of actual nutrients were recorded. So in summary, percent analysis is that complete fertilizer product recorded with either pounds or gallons of that complete fertilizer product. Pounds of actual nutrients is like the ingredients to a complete product. In this case, the nitrogen, phosphorus, potassium, and sulfur. So remember, when reporting by percent analysis, column 3 must be filled in, which is the quantity of fertilizer applied, and column 4 is the material code, must be coded a 1 for pounds or 12 for gallons. When reporting pounds of actual nutrients, column 3 is left blank, and column 4 material code is 19 for pounds of actual nutrients. So this is the reason why this section is called nutrient or fertilizer applications. There's a column called type of nitrogen used. And you're going to ask the farmer, which form of nitrogen did he use? Please refer to the codes above the table. Item 1 is anhydrous ammonia, 8200. Number 2, liquid nitrogen, UAN, is either 28% or 32% nitrogen. Urea is a dry product, it's 4600. Ammonium nitrate is a dry product, and it's 3400. Sodium nitrate is a dry product, it's 1502. Number 6 is ammonium sulfate, it's dry, 210024. Potassium nitrate is dry, it's 13044. Magnesium nitrate is a dry product, it's 1000. And calcium nitrate is dry, 1500. And number 8 is another. Throughout the section, be sure to read the enumerator instructions and follow all skips when appropriate. Also answer yes for 1 and no for 3 where appropriate. It's very important to record nutrient or fertilizer application data correctly. We don't want to underreport or overreport this data. So it is critical to understand the 2 ways to record data in this section. We're not asking you to do the math on this. I showed you this just so you can have a better understanding of what the numbers mean and how they work together. So if you get stuck on any question or have some problems, you can give me a call. Remember, I'm from the government and I'm here to help. Thank you for your time.